Hi everyone, and welcome to this talk about DevSecOps, infrastructure drift, infrastructure as code, and drift CTL. Welcome to stackconf 2021. So in this talk, I will briefly define what is infrastructure drift and what we learned the hard way, and pretty soon it will be fun live demos and stories. This will be a very hands-on talk, so thank you for attending. Basically, last year we were working on a GitOps platform to support infrastructure as code, and all the tooling, all the best practices, etc., ready to use. And at some point, we looked for feedback to build the next features, and we interviewed our users and other DevOps guys like SREs and CTOs and etc. So the most important pain those people reported was around infrastructure drift and all the visibility of what's actually living outside of your Terraform configuration. So if you have only one thing to remember from this talk, it's that almost everyone experienced infrastructure drift recently, and that drifts can have major consequences, including security. So in the end, that's the reason why we built this open source tool called driftctl that I'm going to show in this presentation. So I'm Stephane Jourdan. I'm as Jourdan pretty much everywhere on the internet. I've been around infrastructures for the past 20 years. I co-founded a bunch of companies here and there, Canada and Europe. And many years ago, I co-wrote this book, Infrastructure as Code Cookbook, and more recently, I'm the happy co-founder of this tool, the open source tool driftctl, with a wonderful team. So after talking to hundreds of people, we had to come up with a common definition of infrastructure drift. And it's basically what happens when the reality and the expectation don't match. It's also known as, oh my God, when things go wrong while they really should not, So according to this definition, your AWS account has a ton of actual resources. That's the part on the right. And maybe only part of it is correctly managed by Terraform. That's the part on the left. And the diff is the drift. So what are the causes of drift? There are many, but the major ones are the manual changes directly on the AWS console, all the authenticated lambdas and microservices, or those scripts that runs every night to snapshot those disks on AWS, scan for certain tags, etc. And can be as well this other team working with another tool, or that AWS service not yet available in the current Terraform provider version. So maybe you just had this new project starting on this new cloud provider, or different from the current one, and obviously no time to automate it properly. So all those activities and others are all authenticated and are causes of drift. So it could be no big deal, and maybe we could all live with those drifts. Problem is, misconfiguration can lead to security issues you don't even know about. And we see here in this slide that the NSA recently labeled poor access control and misconfiguration as top issues. So definitely you want to know about the unknown stuff running in your cloud provider's accounts. As we just said, we definitely need to shed some light on the unknown resources of your accounts and those that are not under control with Terraform. And only then you'll know about misconfiguration. Only then you'll be able to address or fix the issues. So I'm done talking about general stuff and context. Let's go for the stories. I'll share a few of them. They are simplified for the talk. They are from our closed environment or ourselves directly. I'll show as well how our open source answer drift control, driftctl, helped in this situation. So the first story is about this authenticated microservice. This team shipped a new version of it on the Friday evening. They went home, weekend stuff, etc. You know the story. And something went wrong during the weekend, and the on-call support team they had to solve this issue, and they read the code and they said, well, okay, so we have here a microservice, we have an IAM access key, we have a read-only policy attachment. Okay, let's find a way around that. So so to check, sorry, here we are. So that's the code basically for those of you who are not familiar with Terraform. So this is a resource that creates an IAM user. That's the name of the resource, and the name of the resource with a dynamically generated string from another state, and that's an access key for this user, and that's the attachment for the said user here. And the attachment is for a managed policy by AWS, and that's the read-only access policy. So basically, this generates an access key with read-only access to AWS for this IAM user. And in this case, the team here went there, and basically they said, okay, let's make inactive this, let's deactivate this access key and create a new one. So we are sure this way that it's not an access key problem. So they tried that, and it worked, but didn't change the issue. So they went to the permission tab, and they added manually a permission. So in this case, it was like something close to that, administrative access. So it's quite different to read-only. And basically, they thought that they would tell the team afterwards, but unfortunately, they forgot about this. So what happened? On Monday, the team they had Terraform plan and apply in CI to ensure the code always was always staying in sync with the reality and the intention. And so in this case, let's try and apply directly. In this case, Terraform apply would not report anything change. So why is that? It's precisely because it's different objects on Terraform side. The way AWS sends things to Terraform in the current iteration of the tool, it might change in the future, but right now it doesn't display any change because it's out of its scope. It's a new key. It's not the key that we declared that was changed. It's just a new key that was added, and the policy is a new attachment. And in this case, the same situation, it cannot be discovered by the current iteration of the tool, the Terraform tool. So in this case, driftctl would be quite helpful because we have a bunch of states in our folder, 4 actually, and by using this simple pattern, we can load them up, all the states. You can have only one state, but you can have many states, and we can launch it. It scans resources against your AWS account. It's using the standard environment variables, and basically what it reports is this new access key here to what IAM user it's related. So it's related to the microservice MRE9 Morella. And so you have a new access key and you have a new attachment as well for this microservice user, this IAM user. So this is probably a huge warning for you. You should be very worried if you see this output on your AWS account. We also added some nice information like coverage, code coverage, like for software engineering, it's very common. So we introduced this notion for infrastructure as code. So in this case, our code it has a 77% coverage of resources because we have those two resources not covered at all by infrastructure as code, by Terraform. So we also have deletions support. So if a resource is deleted, it will be there. And change support as well if you change manually your resource outside of Terraform. So that's the first story, and very unfortunately for this team, this microservice stood run in production for weeks, maybe if not months, with administrative access or nearly administrative access and rogue keys, just because, well, the guys in the team were pretty sure that they were protected by their GitOps pipeline, checking Terraform plan and applies returns, and well, didn't work. In this case, use driftctl for that. The second story is about security groups. At the beginning of the pandemic, people were started to work from home. A couple of people couldn't connect to the company network, and some of them didn't want to wait for IT to solve the issues. They rang their managers and they asked them to do something and do something quickly. And one of them had enough credentials to open everything to everyone on the security group. And well, good for them. It solved the issue. But the manager in question forgot to tell the team the next day. So how does it look like? This is Uplaw. This is a security group. The name is Super Secure, and this security group has only one rule here, and it's 22. It allows SSH from the local network. And basically, there is two ways to write security groups using Terraform. The first one is using separate rules and separate resources, one for rules and the other one for the group. And another way is to use ingress and egress blocks directly in the security group resource. And this team chose to use this solution. And basically, if I do again what the manager did that day, this is our super secure security group. And if we go there and that we add a rule, like the guy added all traffic from anywhere, IPv4, IPv6, and called that rule temp. Very, very good. All right. So in this case, the team as well, they had a very cool pipeline checking for differences between the Terraform code and the reality. But here, once again, 0 added, 0 changed, and 0 destroyed. Same reason than previously. Terraform state is not something you are supposed to mess with or check for yourself. In our case, what would driftctl do taking a little bit of time. All right. So in this case, driftctl says that there is a rule not available, not declared in your Terraform states, and so you have the ID of the security group, you have you have the IPv4 a load range, and the IPv6 a load range, which basically, if you see that in your output, you are in big trouble, especially if you also have access keys and attachments of that kind. So once again, it's simplified for the demo, but that's the idea. And you can see as well that the coverage decreased from 70 something to 63% because you have two new rules unmanaged. So that's it for the story. In the end, someone in the team was manually browsing the AWS account and for the company and notice that this rule, like why is everything opened on this security group, and check around and discovered why, but it stood like this for 4 weeks fully open. This third example is from a team in London, and they were using a lot of data in S3 buckets. They are building a plugin, an enterprise plugin for something, and basically all the developers, like there were like 100 of them, they were building the plugin every hour or so and uploading it to S3 for some QA, etc., and checking for basic stuff. And so it generated a lot of data every day. And in this case, a separate team, another team, they had a compliance and security roadmap for them, and they decided to enable S3 versioning, and as well as do something around, like create a couple of buckets manually, etc. So they went to see the team and said, okay, we have this project, but you will be impacted. Is it okay for you? And so the team I was working with in London, they said, well, if you want, but it's pretty stupid because we really don't need versioning. That's going to be a huge amount of data that will be versioned, and the cost will be huge. So that other team, they were like, oh, great, thanks for telling us. We will not include your buckets in this roadmap because, as you said, it's pretty useless. And everybody went home very happy about the chat. And the guys in London, they had Terraform in CI as well, so they would report if anything bad was changing on was happening to the S3 buckets. And the team with the compliance and security roadmap, they built this wonderful Python script, and with a huge list of exclusion, and then ran it, and they said, okay, if there is an issue, we will know about it because we are reading the output of the scripts, and they did it. And unfortunately, what happened is something like this. So this is the bucket, stackconf demo mre blah blah blah, and basically what they did in the Boto script is enable this like this, and in the end as well, they created a bunch of buckets around. And in this case, what will driftctl report as well, very pretty much the same thing. It scans all your account, And it reports that versioning changed, because basically if you go here S3 Terraform plan, this case, it's refreshing, yeah. Terraform did not detect any difference between your configuration and the remote systems. Once again, it might change soon, because HashiCorp is doing great work building a better tool. But for now, that's the kind of situation that we can see. And in this case, unfortunately, the team that discovered the issue was finance, because they received the bill the next month, and it wasn't that good, as you can imagine. So I have a few minutes left, so actually I can show more usage of the tool. Like you can integrate that kind of output in so driftctl is giving you a lot of data, as you can see. So you can integrate the data with another tool. You can store some data in a database. You can build dashboards with it. You can use the JSON output to do whatever you want with it. Like I personally extract the coverage percentage of this output. So in this case, we output to a file, but you can output to SDD out, so you can pipe the output to something else. Those are the kind of things you can do with that. The JSON output also can be used in conjunction with another command that I'm going to show right now, which is the drift ignore. The drift ignore file, if you start with a lot of unmanaged resources in your AWS account, it works pretty much like a drift, the git ignore file, sorry, that you already know. You put stuff that you want to ignore in it. So it takes a resource type like an IAM user and an ID or a name, depending on the situation. And here we are. It will be ignored from now on. So until well, when you find the time to fix the issue, it won't be reported every time you run the tool. And definitely, I would add this file to your Docker image. So every time you run driftctl with the drift ignore file, you can ship that on CI or have it as a recurring cron, like every hour or so you get reports about what's moving in your infrastructure. So yeah, that's the subcommand gen drift ignore. If you have many drifts and you don't want to enter hundreds of them in the file, I can imagine it's a pain. So you can just use the previous export here, the JSON output, and pipe it inside the drift ignore command. So this is basically a generator, a converter from JSON to drift ignore. So you can get started in seconds. Instead of having hundreds of drifts, now you are starting from a clean state, from fresh, like zero drift. And you still have work to do, but at least you can get reports about the new things. Another feature is the filters. Probably you're not interested by everything in your AWS account past the first days. So probably you want only, I don't know, security reports on security groups, tags, or I don't know, IAM users. So basically you can do this with driftctl filters. So it's using JMSpath. It's a query language. If you are already familiar with the AWS CLI, it's the same. It's the same one. So it's very useful to analyze and report on very specific areas of your AWS accounts. And to get focused reports. So yeah, that's the drift ignore. Well, yeah, as I mentioned, I would build a driftctl Docker image to ship in CI. So we have quite a cool different options to integrate in your pipelines. So as a recurring task, as a cron job, like every hour or so. So you can get alerts when something goes wrong, like in minutes or at least every hour or so. So we've seen different use cases. Some people are using driftctl to ensure all the scripts and stuff done after the last Terraform apply in a pipeline don't create a mess. But we've seen things like the other way around, like people wanting to ensure that the situation is perfectly under control before doing anything with Terraform in the first place. So maybe just like a safety check before Terraform apply changes anything on the state, like the few cases that we just showcased in this situation. So we support, we have examples for GitHub Actions, for Circle CI, for GitLab, for Jenkins. We have them all. So yeah, I strongly advise you to deploy that kind of tools like driftctl in your CI pipeline, exactly like you would get reports by just executing Terraform plan regularly. So we are approaching the end of this talk. So driftctl, it's our open source solution for drift management. It's written in Go. It's an Apache. It's been released as an Apache 2 license. We have support for AWS and GitHub. If you you manage your GitHub account using Terraform, it works as well. We have support for local states, S3 states, HTTP states. We recently released Terraform Cloud backend support as well. So as you saw, we have a cool filtering options, and the drift ignore file as well is very useful for those of you who have big accounts, shared accounts, are in migration, etc. And we are highly available on Discord. So if you go to driftctl.com/d, it will send you to our community Discord. We are there. Talk to us. We love talking to you, hearing your feedback. We also do everything on GitHub, like cloudscape/driftctl. There is a lot of discussions. We are heavily community based for everything related to decisions, product decisions. So please upvote for the next cloud, next features, etc. So we do take those very, very seriously. And we do some live streams sometimes, less Thursdays, but we will do it again with spring coming. So if you joined during the talk and you don't know what I'm talking about, what's to remember basically is that almost everyone is experiencing infrastructure drift, and that we built driftctl, drift control, as an open source tool to help increase the knowledge and security of automated cloud infrastructures. So thank you for your attention, and thanks for watching. See you soon on Discord or on GitHub. Bye-bye.